another important integral, which is a single integral called as a gamma function. The topic in our syllabus is called as beta and gamma functions. Beta and gamma functions. Out of that, we will define gamma n. By definition, it is integral 0 to infinity e raised to minus x into x raised to n minus 1 dx. The definite integral 0 to infinity e raised to minus x into x raised to n minus 1 dx is defined as gamma n. Now if we try to evaluate it, this should be remembered as the definition of the particular function called as gamma. Remember that as we are going to substitute the upper and lower limit values for x will be getting eliminated after integration, and the final answer will remain in terms of n, and that's why it is a function of n and not function of x. Ultimately, you are aware of the fact that the variable of the definite integral, that is x in this case, is very well replaceable by any other variable. You can write it as e raised to minus y into y raised to n minus 1 dy, or you can write it as e raised to minus t into t raised to n minus 1 dt, and so on. Ultimately, after integration, you will be substituting values for that particular variable. At upper limit, it is to be substituted as infinity, and at lower limit, it should be substituted as 0. So the variable that we are introducing for the definite integral, that will get eliminated, and finally answer will remain in terms of n. Now if we integrate it by parts, integrating by parts with our usual rule as x raised to n minus 1, because it is LIATE that we will be again referring to. Logarithmic, inverse, algebraic, trigonometric and exponential. You will have to consider x raised to n minus 1, which is algebraic function, and we should be integrating, or rather we should be choosing x raised to n minus 1 as function 1, and e raised to minus x, which is also integrable, that should be considered as function 2. And if we integrate it by parts, we will get it as retain first, that is x raised to n minus 1, integrate second, e raised to minus x upon minus 1 within limits 0 to infinity, minus integral 0 to infinity, differentiate first, that is n minus 1 x raised to n minus 2, integrate second, that is e raised to minus x upon minus 1 dx. So this will come out to be minus sign outside, it is e raised to minus x into x raised to n minus 1 within limit 0 to infinity. This will be minus minus plus, n minus 1 will come outside, integral 0 to infinity e raised to minus x into x raised to n minus 2 dx. Now when we substitute upper limit, the first term will contain e raised to minus infinity into something like infinity raised to n minus 1. But remember that this e raised to minus infinity term will be tending to 0. So the first term, the term at upper limit, will come out to be 0, minus at lower limit, it will be e raised to 0 into 0 raised to n minus 1. So at both the limits, the value of the first term will be 0, and the second term can be now rewritten as n minus 1 integral 0 to infinity e raised to minus x into x raised to n minus 1 minus 1 dx